Welcome to The Explainer. Today, we are diving into one of the absolute cornerstones of modern tech, something called supervised machine learning. You know, it all really starts with a question you've probably wondered about yourself. How in the world does your phone's photo app know the difference between a picture of your cat and a picture of your dog? The answer isn't some giant complicated rulebook about whiskers and tails. Nope, it's actually something way more human. You see, the whole secret is that these systems learn a lot like we do. They learn from experience, from looking at what's come before. Supervised learning is all about showing a machine a ton of examples. And I mean a ton, thousands, sometimes millions of them. We feed it picture after picture, and each one has a label on it. Cat, dog, cat, cat, dog. And after a while, the machine just starts to get it. It begins to figure out the patterns, all on its own. Okay, so how does that learning process actually work under the hood? Well, it turns out there's a simple but really powerful recipe that it follows, and it's all about having the right ingredients to start with. The key, and the magic word here, is supervised. Now, this doesn't mean that some person is sitting there watching it 24/7, not at all. It means the data is the supervisor. Every single piece of data we give it comes with the correct answer already attached. We call that the label. And that label guides the model, basically telling it, you got this one right, or nope, try again. And every single piece of that data has two fundamental parts. You've got your features. Think of these as the questions you're asking. For an image, that could be all of the pixel data. And then you have the label. That's the answer key. That's the correct answer we want the model to eventually figure out, like the word cat. The whole game is just learning the connection between the questions and the answer. And this is the engine that drives it all. The machine is stuck in this constant learning loop. First, it takes a guess, a prediction. Then it compares that guess to the real answer we gave it. It figures out how wrong it was, that's the error. And then, this is the secret sauce. It updates its own internal logic to be a little less wrong next time. This update is where different algorithms do their thing. Some, like linear regression, are trying to draw a line through the data. Others, like a decision tree, learn a bunch of if-then rules. But whatever the strategy, it's just rinse and repeat, millions and millions of times. It's not memorizing, it's refining. So, once a machine gets really good at this learning loop, what can you actually do with it? Well, it's pretty much used for two main jobs, either sorting things into groups or trying to predict a specific number. Let's break that down. So, it really boils down to this: classification versus regression. Classification is all about answering the question, what kind of thing is this? The whole point is to stick it in a category, like spam or not spam. But regression, that's all about answering how much. It's trying to predict an actual number, like the price of a house. And you see classification work all the time. It's the engine that powers your spam filter, deciding if an email is junk or not. It's used in medicine to help tell if a tumor is malignant or benign. And your bank uses it to flag a transaction as possible fraud. The answer is always a clear-cut category. On the other hand, regression is what's behind those real estate websites that guess a house's value. It's what businesses use to forecast next quarter's sales, and what meteorologists use to predict tomorrow's temperature. The answer is always a number that can fall anywhere on a spectrum. Okay, now, this next part. This is maybe the single most important lesson in all of machine learning. Seriously. And I'm betting it's not what you think. It has nothing to do with finding the fanciest, most complicated math. There's a saying in this field that captures it perfectly. In the real world, what makes an AI system great isn't some genius-level algorithm, whether it's a simple decision tree or a massive neural network. It's the data you feed it. A pretty simple model trained on amazing data will crush a super complex model trained on just okay data, every single time. And that's because a model is only ever as good as the data it learns from. You've heard the phrase garbage in, garbage out, right? Well, in machine learning, that's not just a saying, it's the law. If your data is messy or wrong or biased, the model will learn those flaws perfectly. So, to make sure our model has actually learned the general rules and hasn't just memorized the answer key, we do something really clever. We split our data. We take most of it, maybe 80%, and use that to train the model. That's the training set. But we keep a smaller chunk, say 20%, hidden away. That's the test set. And we use it to see how the model does on stuff it's never, ever seen before. That's the final exam. That's the real test of learning. But, and this is a huge but, this complete and total reliance on data brings us to a really serious problem. It means we have to face the very real risk of accidentally building our own worst biases right into these incredible systems. So what happens when the data we use to train these things reflects a biased history? Well, the model has no idea. It doesn't know about fairness or history. It just sees patterns. So it learns from the world as it was, not as we think it should be. And in the process, it can actually end up amplifying the very biases we're trying so hard to fix.
Let me give you a real-world example. A major healthcare algorithm was built to predict which patients were the sickest and needed more care. But instead of measuring sickness directly, it took a shortcut. It used how much a person had spent on healthcare in the past as a stand-in for how sick they were. The problem? Because of systemic inequities, Black patients, for the same level of illness, had historically spent less. The AI learned that flawed connection perfectly, and as a result, it started systematically flagging Black patients as healthier than they actually were.
And that right there brings us to the most important takeaway. Really getting your head around these ideas, from the learning loop to the power of data to the risks, it's about more than just technology. It's about learning a new way to think. And this is the mindset that separates people who just use AI from the people who actually build it, lead with it, and make responsible decisions about it. Because at the end of the day, the most important question isn't, what can this AI do? It's, what hidden lessons did it learn from us to be able to do it?